This is Advanced Math 9.3 notes. That's Unit 9, Lesson 3. The title is Long Division and Synthetic Division. We are going to start off with long division, and then we will move on to synthetic division. Okay, before we discuss long division with variables, I want to do a little itty-bitty over here, quick review, long division with just numbers, and how you did in elementary school. 476 divided by 3. I was told my division symbol looked like a square root, so I'll try to fix that. All right, go ahead and work that out best you can, remembering what your elementary school teachers taught you. Oh, and write your final answer not as a decimal. I'd like it as a mixed number. If you remember how to write it in mixed number form. If you don't remember, then in remainder form. Alright, did you guys get it? Check with your shoulder partner. If you don't have a shoulder partner, check with the person in front or behind you. And if you do have a shoulder partner, can you check around you? If people don't, check with them. If they don't have a shoulder partner, check in on them and see what they got. Alright, how'd you guys do? Has it been a while? Do you guys remember how to do it?
Yeah.
Okay. 3 goes into 4 how many times? Alright, now guys, we want to remember the process, not just, I'm not giving you just this just because. We want to remember the process, the steps. What's the next thing we do? Not, you're a step ahead of me. What do we do here? Multiply. 3 times 1 is, and then we subtract going down. 4 minus 3 is, what do I do next? Drop that 7, and then we start all over, yes? 3 divides into 17, and where do I put the 5? Down here, the top, and then I multiply and put that number down here, and then I again subtract, and again bring down, and again divide, and that goes in 8, put it up here, multiply, subtract again, and that's my remainder. Remember when you were itty-bitty and you put R2? Yes? We didn't put R2 now because I told you I wanted it in mixed number form. You put 2 over 3. Some kids said they don't remember learning that. Do you guys, some of you feel that?
I forgot about that. Usually I just put it as a decimal.
Yeah, no decimals. I didn't want decimals this time. How many of you guys remember writing it in mixed fraction form? Yeah? You guys all did, whether you remember it or not. I had a lot of people say, no, I never did. You did. You just may not remember it, but you did at some point in your life. Okay. Steps, we just want to remember the steps because we're going to use it today to do this with variables. Are we ready? Parentheses 5x squared minus 7x minus 12, close parentheses, divided by parentheses x minus 4, close parentheses. And then I'm going to set up division, and I'm going to move that just a smidge bit lower. The x minus 4 goes on the outside. 5x squared minus 7x minus 12 goes on the inside. Okay, are you ready? Okay, now there's a big problem, like there's a big piece, but we just focus on itty bitty pieces, and then eventually we work with the whole thing. Okay, so focusing just here, you ask yourself, x times what is 5x squared? Do you guys agree that x times 5x is 5x squared? Okay. Then that is what I write up here. Just like I wrote the 1 up there. And then I did 3 times 1 to get the number underneath, right? Okay. I'm going to do the same thing, 5x times x. But, like I said earlier, I covered it, but technically there is a bigger piece, and I do have to work with the whole piece. So, I do have to do 5x times all of it. So, just watch for now. I'm going to do 5x times x. What is 5x times x? And then what's 5x times negative 4? Okay, so go ahead and write that down. I'm going to repeat what I did. I covered here and here to figure out x times what was 5x squared, and you guys gave me 5x. And after I figured out it was 5x, I then distributed the 5x to the x minus 4. 5x times x is 5x squared. 5x times negative 4 is negative 20x. Questions before I continue? All right, over on our previous review problem over here, what did we do going down with the 4 and the 3? Did we add or subtract? Okay, the only thing is here, I'm subtracting multiple terms, so pay attention. I'm going to do 5x squared minus 5x squared, and negative 7x minus negative 20, which would change that to a plus. Make sense? Because I'm subtracting multiple terms, I have to pretty much change both of these signs. Subtract, subtract, which changed that to a plus. Okay, what happens here? What happens to these two terms? That's always going to happen. Your first set of terms should always cancel out. Here, you're going to combine what's negative 7x plus 20x. I'm sorry. I did mess up, so please do not go any further because it's going to mess up the whole problem. So I'm hoping nobody's gone further. This, I just wrote it down wrong. This should be the 17. Please fix it. All right, so not 7, but 17. What's negative 17 plus 20? 3x. And then like we brought the 6 down, we're going to bring down the minus what? Okay. And then, like we did over here where we started all over, 3 goes into 17 how many times? We're going to start all over. I'm going to cover and cover and ask you guys, x times what is 3x? Positive 3 or negative 3? So up here I'm going to put a plus 3. And then I'm going to multiply, but I'm going to multiply to both the x and the minus 4. So distribute. 3 times x is 3x. 3 times negative 4 is minus 12. 3 times negative 4 is negative 12. We subtract both of them, so 3x minus x, negative 12 minus negative 12 becomes plus 12. What happens with these first terms? They should always cancel out. Anything else that cancels out is just bonus. Do these two terms also cancel out? That's just bonus. They don't always cancel out, but the first sets should always cancel out. What do I end up with here? That means my remainder is 0, which means 5x plus 3 is my answer. My remainder is 0. In this particular problem, the remainder of 0 just means that 5x squared minus 17x minus 12 was factorable. So kids will say, well, why didn't I just factor? Because in your textbooks that you will have them where they say complete using long division, so you will have to show your work using long division. Got it? And they're not all going to be factorable. You will have some that do not have a remainder of 0. Questions before I continue? Okay. Number 2. X plus 2 divides into x to the 4th plus 5x cubed plus 6x squared minus x minus 2. All right, I'm going to start you off and then have you work with your shoulder partner. Alexis, I'm going to have you sit over here next to Akash since both of you guys are missing shoulder partners. And I'm going to have you move your chair either next to either one of them. You can decide what's easiest. Okay. Are you guys ready? Okay, I'm going to start you off. I'm going to cover and cover. X times what is x to the 4th? I heard somebody whispering. X cubed. Do you guys agree it's x cubed? Okay. And then I distribute. X cubed times x is x to the 4th. What's x cubed times 2? Positive 2x cubed. Yes or no? Okay. I pretty much just change both signs because I subtract this one and I subtract this one, so I change my two signs. First one should always cancel out. What's 5x cubed plus negative 2x cubed? 3x cubed. And I'm going to let you guys continue from there. Check with your shoulder partner. If any of you are further ahead, you do end up with the remainder of 0 on this one as well. Or any of you that far ahead? Okay. What did you guys get as your next number up here? Plus what? plus 3x squared? Does everybody agree? Yes?
Yeah.
Did anybody get confused with this next step? Because you end up with 3x cubed plus 6x squared, and what ends up happening to both terms? Does that usually happen? No, I've said the first one should, and if the extra one does, it's just bonus. Did that confuse anybody? Some? Okay. That's okay. If it happens, you just drop down the next two and continue. All right. So in this one, two terms end up canceling out. So you drop the minus x and the minus 2 and continue. All right, what's the next number going to be at the top? -1. After the 0 is at -1. And then you get minus x minus 2. Change your two signs, because if you subtract, it becomes positive, positive. Do they both cross out with the remainder of 0? Then this here is your answer. Questions? No questions? Akash, no questions? Okay. Number 3. X squared plus 1 divides into x to the 4th plus x cubed plus 5x squared. And pause before you work ahead for those of you that work ahead. How many of you are working in pen? Okay. If you're working in pen, either have whiteout or change to pencil, or you don't care if it looks a little wonky, because it's going to look a little wonky eventually with this particular problem. So you either don't care that it looks a little wonky, or you change to pencil, or you have whiteout. One of those three. Or you borrow my whiteout. Is that it? Okay. Because this one's going to look a little wonky. We're ready? All right. X squared times what is x to the 4th? X squared, do we all agree? Okay, x squared times x squared is x to the 4th. Distribute then to the next term. X squared times 1 is positive x squared. Change our two signs, minus and minus. Does the first one cross out like it should? All right, what's wonky about this one that hasn't happened on the last two? What was that? Are those like terms? No. Okay. You have choices. Leave it like this, knowing these are not like terms, and see that x squared's like term is elsewhere. Does that bother anybody to see? Some kids in my other class were like, oh, I can work with it. X squared is by itself and x squared's term is over there. I can combine like long distance. How many of you look at that and like it bothers you to see it out of order? Does it bother any of you? If it bothers you, then you erase or white out and rewrite it where it should be. Where should that x squared go? Underneath the what? and then change its sign. So it's up to you on how you write it. Leave it where it was, and in your head, mentally put it where it should be, or erase it or white it out and then put it where it should be. Got it? But know where it was originally was not with its like term, and that happens sometimes. You either mentally put it with its like term or rewrite it and put it with its like term. Does that make sense? How many of you feel like you're one where you would rewrite it and put it with its like term? How many of you would leave it where it was and mentally do it with its like term? Okay, you do what works best for you. Okay, first one still crosses out. X cubed doesn't have a like term, so I'm going to drop it. And that becomes plus 4x squared. And then we start over. X cubed times what? X squared times what is x cubed? X, positive x. All right, and then I distribute. That gives me x cubed plus x. Is plus x with this like term, yes or no? So I'm going to put it over here. It doesn't have a like term, it's just kind of hanging out at the end. I'm going to subtract and subtract. This one cancels out. And do either of these guys have like terms? No. So drop the 4x squared and the minus x. And you still continue. X squared times what is positive 4x squared? Positive 4? And distribute. In this one, I'm going to purposely put it like in the wrong spot, so I get 4x squared plus 4, just to show you that you can do it in the wrong spot and mentally take care of it. Minus, minus, gone. And I can see that these are not like terms, so I cannot combine them. How do I write it? Negative 4 minus x or negative x minus 4? Negative x minus 4. They're not like terms. Now you didn't have to write it at all like I did. You could have done what I said earlier. You put the minus 4 over in its own spot. You do what works best for you. Can I continue without, I only want positive exponents. Can I continue using only positive exponents? No, right? X squared times nothing is going to give me x, or negative x, right? That is my remainder. And I don't put r, remainder negative x minus 4. I'm going to write it like I did here. Only thing is I'm going to put plus 2/3 like that. So here I'm going to put plus negative x minus 4 over what I divided by, x squared plus 1. That there is my answer. Questions? All right, questions on any of the long division problems with remainders, with no remainders, questions on any of them? Questions on what to do when things don't line up properly? Yes. Okay, you have to speak up a smidge bit because I heard something about remainders. This is the remainder, and I didn't hear anything after that.
So, after we stop the remainder, why would we stop the remainder?
You can't. What else could we do after this? X squared times nothing is negative x. Right? Only positive exponents. X squared times nothing with a positive exponent would give me negative x. Yeah, so that would be my remainder. Okay. All right. questions before I move on to the synthetic part? All right. Anybody need this up a little bit longer? Next piece, synthetic division. All right. Does this problem look familiar? Is this the same one we did as number 1? Can anybody check? Is it the same? Okay. We're going to do it again, only this time we're going to do it again, but we're going to use synthetic division instead of long division. So we're going to work it out synthetically. We're ready? Okay, here's how it works. You're going to always have a little number in this corner little typed box here. And the number you put in there, it's just going to be a number. You're going to always take whatever's given here, the dividing piece, whatever you're dividing by, and you're going to set it equal to 0. X minus 4 equals 0. You solve, what do you get? X equals 4. So you pretty much take the opposite. If it was x plus 4 equals 0, you would get negative 4. Now, sometimes they will give it to you already solved. They'll give you x equals 4. When they give it to you as x equals, you just put the number in. When they give it to you as like a factor, x minus 4, then you solve and take the opposite. Make sense? Okay. Here, we're going to have a list of numbers. I need you guys paying attention. Okay, a list of numbers. You're going to grab your coefficients. But, a few things you have to remember. It needs to go in descending order. Is it in descending order? Yes. And all of your exponents need to be accounted for. So, second power, first power, no power. Is everything there and in order? Yes, then we can continue. If not everything's there, we have to put placeholders with zeros. We'll see that on the next one. So I grab only my coefficients, no variables. So 5, negative 17, negative 12. Ready? Abby, paying attention? Okay, this is new. Oh, by the way, I did forget to mention this earlier. We're finally learning new stuff because this is something you did not learn in Math 3. Unless you came from Math 3 Honors, this is something you have not seen before. Finally, because everything else we've been doing is review. All right, we're ready? Okay. Steps. First thing you do, you always drop the first number. There's nothing to do with the 5 other than drop it. And then these next few steps, you're going to continue the pattern over and over till you get to the end. What's 4 times 5? 20. You multiply these two numbers. And then you add going up and down. What's negative 17 plus 20? And then you multiply. What's 4 times 3? And then you add. What's negative 12 plus 12? That last number is always your remainder. That line is just to represent my last number. Did I have a remainder of 0? On number 1. Was it a remainder of 0? And here is how I figure out the answer. Everybody ready? What's the degree here? What was it? X squared. I always decrease by 1. What's 2 decreased by 1? So x squared becomes x. So 5x plus 3. And that's my answer. Can you guys flip back to number 1? Was that the answer for number 1? exactly the same. Okay, so kids often ask, do we have to use long division? On today's lesson, you will have some where it says work these out using long division, so yes, you do. Yes, you have to use long division. You will have some where it says work these out using synthetic. Yes, you will have to use synthetic on those problems. After today, for the most part, we're going to be using only synthetic after today. On the test, there is one problem, only one, where you have to use long division. And I will prepare you, we will review it. We're not going to just like throw it out. I'm not going to just throw it at you. I will prepare you, review it, go over it, so you're ready for that one problem. But synthetic is what we're going to be doing for the most part for the test. Well, you need to know long division for at least one problem, but I will go over and review it before the test. Yes? Yeah. Okay, questions about, I have one more to go over before I do. Any questions about long division or synthetic? Okay. Next one, 5x cubed plus 6x plus 8 divided by x plus 2. Ted? Ready? All right, what number goes in the box? -2. All right, our degree is 3, decrease, third power, second power, first power, no power. Is everything there? Or is there something missing? Which one's missing? X squared. So you do have to rewrite it, or at least mentally rewrite it. 5x cubed plus, which one was missing, the x squared? 0x squared plus 6x plus 8. Third power, second power, first power, no power. Now is everything there? Okay, everything needs to be there in order. If it's not, what do you put as its placeholder? 0. Okay, grab all the coefficients. 5, 0, then the 6, 5, 0, 6, 8. So pretty much if you have a degree of 3, you should have 4 terms. You have a degree of 2, you should have 3. All right. Drop your first number. Multiply and add, multiply and add, multiply and add. Your last number is your remainder. I'm going to have you guys do that now. I'm going to tell you that the last number is not 0. Your remainder is not 0. But go ahead and work it out. There's calculators up front if you'd like one. A good question was asked, what if the constant at the end is missing? Do you need to add a 0 there as well? Yes. Even the constant needs to be accounted for. Make sense? All right, did you guys get a number at the end? Not yet? Check with your shoulder partner. If you're afraid to say it out loud, check with your shoulder partner. 40 something. Unless I wrote it down wrong. 5068 negative 2. No, it's negative 40 something. All right, what did you guys do here? Multiply? No? Who said no? Negative 2 times 5 is negative 10. What's 0 plus negative 10? Negative 10. Multiply, add, multiply, add. Keep going. Do you want me to continue, or you guys have got it? Continue? Okay, what's negative 2 times negative 10? What's 6 plus 20? Oh, not 20. What did you say, 26? And then negative 2 times 26? Negative 52. And 8 plus negative 52? Anybody get that? Either on your own or with me, and it made sense. Okay. Now, third power, what's 1 degree less than the third power? X squared. So my answer is going to start with an x squared and decrease. So 5x squared minus 10x plus 26. This is my remainder before I do that. Any questions on where I got 5x squared minus 10x plus 26? I like using plus every single time, but yes, you can do minus 44 plus negative 44 over x plus 2. Questions? Yes.
How'd you get the squared part of 5?
Anybody answer that? Why did I use 5x squared and not 5x cubed or 5x to the 4th? Anybody answer that question? That was a good question. Anybody know? Why did I get the x squared next to the 5?
Is it because you're dividing by x plus 2? Wait, what are you asking?
The question was, why did I use x squared?
Is it because it's a power less than x cubed?
It's because it's 1 power less than x cubed. Good job. Yes.
If you were dividing by x squared plus 2, would you subtract 2 or do you still subtract 4?
Good question. I do want to answer that because that's a very, very good question, but let me finish going over that. Did that answer your question? Okay, so it's 1 power less than x cubed. So x cubed becomes x squared. X squared became x. If this was x to the 4th, whatever here would become x to the 3rd. Everybody understand that? Okay. Now her question, I need everybody listening because that has not come up all day and I should have gone over it with my other classes. Can you repeat it?
If you were dividing by x squared plus 2, would you subtract 2 instead of 4?
Okay. Whenever you're doing synthetic, you can only use synthetic for something basic like x plus 2, x minus 3. They can't be squareds or anything like that. It could only be binomials with x degrees of 1s. X plus 2, x minus 3s, or x minus 1/2, but no x squareds or x cubes. These can only be x functions. So I couldn't use it. I could use it on that one and that one, but not that one. Make sense? That was a good question. Did you guys all hear her question and the answer? Yes. Yes, you may. All right, any others?